Okay, this is the section 4.5. Finished up the notes from in class. I can't remember exactly which sections got to which problems, but we're going to look at number D, or part D, I should say, for 4.5, and note that this is a factorable rational, and that is there's a cancellation, which means there's a whole, and the rest of the part in the denominator will be a vertical asymptote. So the domain errors are both of the values, so -1 and 3, but x equals 3 is the vertical asymptote, and we have a whole at -1, because x plus 1 equals 0 would give me -1. We plug that into the reduced function and get 1 over -1 minus 3 equals -1/4. If you cover up all the x's at the beginning, you see that your y value is 1 over -3. That's your y-intercept, so that should be negative. And our top is a smaller degree than our bottom, so we can't divide, so that means our horizontal asymptote is y equals 0. So then we want to graph this one. There's our horizontal asymptote. Here is our vertical asymptote. Our whole is -1, -1/4. Our y-intercept is -1/3. And we have to question whether or not we can cross the horizontal asymptote here. If you set 0 equal to the reduced part and you try to cross multiply, you get 0 equals 1, which doesn't make sense. So that means that this has to be stuck in this region and kind of go with the boundary. And then we need a value over here to see if we're on top or bottom. So we would pick maybe +5. So plug in 5 to the reduced form. That gives you 1/2. So this would be the 0.5 1/2. So that means this guy is on the top half of the graph. For E, you notice that we get 2 over x plus 1 squared. We do have a domain issue at -1. It is also a vertical asymptote because there's nothing to cancel out. Degree of the bottom is squared, so this is y equals 0 again, because the top is degree 0. No obliques, no x-intercepts because no x is on top, and our y-intercept is what you get when you plug in 0 for all of the x's. So 0, 2 is my y-intercept. I have a vertical asymptote at -1. Have a horizontal asymptote at y equals 0. Do we cross our HA? You take the value of the horizontal asymptote and you set it equal to the function. And when we try to cross multiply, we get 0 equals 2, which doesn't make sense, which means we can't solve or cross our horizontal asymptote. So this guy has to go up towards his boundary and then down towards this boundary. And then what we care about is if we're up or down on the other side. So maybe we'll pick -4. So f of -4 is 2 times -4 plus 1 squared. That is 2 over -3 squared. That is 2/9. So -4 is at 2/9. So notice we are up on both the left and the right side. That is because the denominator is being squared. For f, we had something that factors in the denominator. You get x plus 2 and x minus 2, so 2 domain errors. Neither one of them cancels out, so they're both vertical asymptotes. Y equals 0 because the top degree is smaller than the bottom. x-intercept would be the x value that we get when we solve the top. So that's -4, 0. And if you plug in 0 for all the x's, you get -4 and +4. So that makes -1 overall when you divide. So this one, when we draw it, we get our vertical asymptote at x equals -2. We have another vertical asymptote at x equals +2. We have a horizontal asymptote at y equals 0. And we know our x-intercept is -4, 0. That already tells me we're going to cross the horizontal asymptote because it's touching it, possibly cross it anyways. And our y-intercept is -1. So we need to know, do we cross our HA? If you set the value of the horizontal equal to the function, when you cross multiply this time, there's still going to be x's on top. In fact, you get 0 equals x plus 4, so that solves to -4. So that just means this is the only location that we can cross. We don't know if we're going to be up or down or up, so we need to pick some points. So I'm going to make an XY chart. I'm going to pick -3 and -5 for the what's happening on each side of this x-intercept. I already know that since this only crosses at -4, that this can't cross any of my asymptotes, especially the vertical or the horizontal. And I don't know enough about the last group, so it has to be either up or down, so we're going to pick +4. If you plug in -3, -3 plus 4 is 1, over -3 squared is 9, minus 4 is 5, so this would be 1/5. If you plug in -5, that's -1 over on top and 21 on bottom. And if you plug in 4, that is 8 over 12, which is 2/3. So if we plot these, -3 is at 1/5. So we are hovering above this asymptote. I did that backwards. I graphed backwards. -3 1/5 is over here, sorry. So that means this part is up. And obviously we're crossing, and when you see that -5 comes out as -1/21. So now we are headed this way. And then our last region is 4 2/3, so that means this one is completely up. Because remember, if you do this test, it always tells you only the places you can cross. Okay, so we look at G. This factors into x minus 4, x plus 1, x plus 3, x minus 2. Nothing cancels, so both bottom numbers are vertical asymptotes. Both top numbers are x-intercepts. Because the degrees match, then y equals 1, the coefficients, 1 over 1. If you just look at the last constant numbers, -4 over -6 is +2/3. So if we plot what we know, we have -3 is a vertical asymptote. Sorry, one of these is supposed to be positive. This is +2, which will change things. So that is the vertical asymptote at -3. +2 also has a vertical asymptote. Or not vertical, sorry. Yeah, vertical. It's very late, so x equals 2 is vertical. And then y equals +1 is my horizontal. So 1 above the x-axis. And then my x-intercepts are -1 and 4, 0. And my y-intercept is 0 2/3. We want to know, do we cross our horizontal asymptote? So we set the entire function equal to 1 this time because our horizontal asymptote is positive 1. And you cross multiply. You get the first polynomial and the second polynomial equal to each other. We try to solve for x squared by moving them over, so that just cancels out. I would add 3x over, that would make that 4x. Add the 6 over, that would make that 2, so x equals 1/2. And that's not an intercept, so we need to figure out why it crosses at 1/2 and what's going on there. So what point would that be? One-half squared minus 3 times 1/2 minus 4. That's 1/4 minus 3/2 minus 4. My denominator would be 1/4 plus 1/2 minus 6. Getting a common denominator. This is times 2 times 2 times 4 times 4, because you can think of that being over 1. That would make that 1 minus 6 minus 16 all over 4. And do the same thing down here. This would make this 1 plus 2 minus 24 over 4. And that comes out to negative 21 over 4 over negative 21 over 4, which equals positive 1. So of course that makes sense because you're crossing the horizontal asymptote. So at 1/2, we're going to cross at positive 1. Kind of want to know what the graph is doing in between here. In fact, did we graph everything correctly? Oh, I've graphed my y-intercept incorrectly. I knew something didn't look right. Nothing was lining up. 0 2/3 is right here. Okay, so that makes more sense. This looks like it's going and crossing through up here and staying down here because we cross at that point. Let's see, this tells me I'm down in the bottom corner. And then I need a test value over here. So if I plug in, let's say negative 4, that'd be negative 8 times negative 3 over negative 1 times negative 6. That is 24 divided by 6, which is 4. So we definitely see that the graph is trending towards that staying in that corner. Okay, the last one has a higher degree on top, so we have to do long division to find the oblique. And I did that and got 2x plus 3. The y-intercept is negative 3 over negative 2, so that would be positive 3/2 for the y-intercept. We also would need to factor the top, which I did, and you got x plus 1 and 2x minus 3. So our x-intercepts are negative 1 and 3/2. Vertical asymptote is positive 2. So let's plot that on the board. To plot an oblique asymptote, you must plot the y-intercept first. So there's positive 3. And we use the slope, so up 2 over 1, up 2 over 1, up 2 over 1. You could also go down 2, left 1, down 2, left 1. And draw a dashed line the best you can from that. And then we want to know where do we have graphs, so let's plot what we know. So we have this -1, 0. We have 1.5, 0. And we have 0, 1.5. So it looks like this graph is kind of staying in this corner piece right here. That means we probably have graph up in this tiny piece right here because usually there's some kind of mirror, but we'll test. So maybe we want to plug in +3. So f of 3 equals 3 plus 1, 2 times 3 minus 3, and 3 minus 2. So that's 4. 2 times so that's going to be, sorry, I lost my train of thought on this guy. That's 6 minus 3 over 3 minus 2 is 1, so this would be 12, which definitely fits in with that being in this piece up here. So it looks like the graph is going to be stuck in these two pieces. And that is the end of, because you can't have graph down here because you'd fail the vertical line test, and you can't have graph over here because you'd already failed the vertical line test. So that is how you deal with an oblique, and that is how you graph some rational functions.